Hello everyone, I'm Junisal Guyada and this is my report. Basic tools of quality control, check sheet, and control chart. My objective is introduce check sheet and control chart, enumerate and explain the types of check sheet and control chart, understand the function of two tools of quality control, assess applicability of the two tools of quality control to management functions. So what is check sheet? The check sheet is a simple document that is used for collecting data in real time and at the location where the data is generated. The document is typically blank form that is designed for the quick, easy, and efficient recording of the desired information, which can be either quantitative or qualitative. When the information is quantitative, the check sheet is sometimes called a tally sheet. The check sheet is one of the 7 basic tools of quality control made popular by Dr. Kaoru Ishikawa. Well, check sheet is a simple form designed to record and quantify facts and data over a period of time. The construction of the check sheet should be tailored to collect data on a specific categories, location of things like defects, the frequency of those defects, and possible causes of those viewed defects. A check sheet allows us to collect it with minimal effort to simply use your favorite pencil and paper, and you can record data using a check sheet. You can use this raw data and convert it into useful information, and essentially what it does is that can translate opinions of what is happening into what is actually happening. So in other words, instead of asking, I think the problem is as on stage the data says that the problems is so, check sheets is going to give you some evidence for this. When to use check sheet? When data can be observed and collected repeatedly by the same person or at the same location. When collecting data on the frequency or patterns of events, problems, defects, defect location, defect causes, or similar issues. When collecting data from production process. To use a check sheet, well, first of all, observe an operation and record of specific data over time. A check sheet could be the simple tool that you could use. Secondly, we could use a check sheet to acquire a short-term observation of process variability on the current situation. Thirdly, we could use check sheet to identify what potential problems should be addressed first. And finally, we could use a check sheets to confirm the effects of a problem. So quite simply, a check sheet is a simple tool for measuring quality. There are two types of check sheet: tabular check sheet or tally sheet, and graphical or distribution check sheet. The tabular check sheet or tally sheet is commonly used to collect data on quality problems and to determine the frequency of events. For example, the tally sheet is useful for understanding the reasons patients are arriving late for appointment, causes for delays in getting the lab results back. It is useful in determining frequency of occurrence, such as number of people in the line for blood tests at 6 a.m. to 16:15 a.m., etc., to understand the staffing needs. While graphical or distribution check sheet is using the graphical form, the person collecting the data is able to visualize the distribution of the data. For example, the number of people in line at the registration desk at 15-minute intervals could be counted to determine the staffing needs and the size of waiting room. In conclusion, Check sheet is simple document that is used for collecting data in real time and at the location where the data is generated. The document is typically blank form that is designed for the quick, easy, and efficient recording of the desired information, which can be either quantitative or qualitative. So next is control chart. Control chart was invented by Walter A. Shewhart while working for Bell Labs in the 1920s. Control chart, also known as the Shewhart chart or process behavior chart, is a tool used to determine whether a manufacturing or business process is in a state of statistical control or not. Control chart is a specific kind of run chart that allows significant change to be differentiated from the natural variety of the process. Basically, a control chart is a statistical tool used to distinguish between process variation resulting from common cause variation resulting from special cause. When to use control chart? When controlling ongoing process by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable in statistical control. When analyzing patterns of process variation from special cause, non-routine events, or common cause built into the process. When determining whether your quality improvement project should aim to prevent specific problems or to make fundamental change to the process. Two variations of control chart: common cause variation and special cause variation. Common cause variation are natural issues, noise within the process, and random thought variation are problems, but as it is an inherent part of the process, it is expected variation. Due to common cause tells us that the process is healthy, absence of variation due to common cause indicate some problem in the process. For example is vibration in industrial processes and ambient temperature or humidity or normal wear and tear. Special cause variation are issues developed in a process. These variations were not observed previously and are unusual. They are some kind of defects in the system. Therefore, special cause variation must be identified and resolved for the process to deliver quality products. Special cause variation arrives as a surprise as they are not expected and not welcome. For example is faulty controllers, machine malfunction, poor batch of raw materials, and power surge. Types of control charts. Control charts fall into two categories: variable and attribute control charts. Variable data. These charts are used to achieve and maintain an acceptable quality level for a process whose output product can be subjected to quantitative measurement or dimensional checks such as size of a hole. For example is thermometer, a weighting scale, or a tape rule, diameter or the length of a screw or bolt, wall thickness of a pipe, etc. Attribute data. These charts are used to achieve and maintain an acceptable quality level for a process whose output products are not subjected to dimensional or quantitative measurement but can be classified as a good or bad, acceptable and not non-acceptable. For example, is surface finish of a product, brightness of an item is either acceptable or not acceptable. In conclusion, control chart was invented by Walter A. Shewhart while he was working for Bell Labs in 20s. Control charts have been used in a variety of industries as part of process improvement methodology. A control chart, sometimes called the Shewhart chart, statistical process control chart or an SPC chart is one of several graphical tools typically used in quality control analysis to understand how a process changes over time. Control chart are used to monitor process variation over time, differentiate between special cause and common cause variation, assess effectiveness of changes, communicate process performance. And that's all. Take care.